So let's look back at our infection model from the last video. X prime equals 3x, where x is the number of infected people. Now I want to ask, what does this number 3 actually mean? So first of all, it has units. So we cannot really say what it means unless we specify what are the units. And I'll explain in a moment why 3 must have units. But for now, let's specify some units for t and for x. Well, x we already specified, actually. It's the number of infected people. So the units for x are people. And the units for t, well, t is time, and we didn't really specify a unit. We must specify a unit for this discussion to make sense and for the presence of a 3 here to have any meaning. So let's say t is in days. Then one way to try to interpret what 3 means here is to observe that 3 is x prime over x, right? Just rearranging the differential equation. X prime is the rate of change of x. X is the number of infected people. T is days. So x prime, let me write it like this. X prime is dx dt. Then I'm dividing by x. So dx dt is the rate of growth of the number of infected people per day, or it's the number of new infections per day. That's dx dt. And then I'm dividing by the number of the number of infections currently. So it looks like 3 here is this ratio, the number of new infections per day per existing infection. So that's a nice way to describe what that number is. So let's write that down. Number of new infections per day per infected person. Now, it's tempting from this description of this number, it's tempting to say, oh, so if I look at a duration of 1 day, then 3 is the number of new infections per current existing infection. And so it's the number of people that one person would infect over the course of a day. That sounds pretty sensible, that this is saying one person infects 3 people over the course of a day. But that's not strictly right. So let's actually think about the number of people infected, the number of new people infected per currently infected person. Over the course of a day. Let's compute this, and I just want to show you that it's not 3, despite the correct description of 3 here as the number of infections per day per currently infected person. The number of new infections per currently infected person over the course of exactly 1 day, to compute that, I actually need the solution. So I'll focus on the general solution. So when the differential equation was x prime equals 3x, the solution ended up being x equals a e to the 3t. Now, over the course of a day, how many new infections are there? So if my day starts at a particular time t, then 1 day later, the number of infections is this, ae to the 3t plus 1. And if I now subtract the number of infections to begin with, then this difference is the number of new infections that appear over the course of a day. And if I want that per the number of infections the current number of infections, then I should divide by AE to the 3t, which is what is the current number of infections. And there's some cancellations here, so that's nice. It looks promising at first, but it looks like we get e to the 3 minus 1 after you do all the cancellations. And that, I don't know what that is, but it's definitely not 3. So this is what we got for the number of new infections over the course of a day, rather than 3. So what gives? What's going on here? Well, here when we use the word per, when we say 3 is the number of new infections per day per infected person, we're talking about instantaneous rate of change. This per day, this is instantaneous. It's not about it's not about a duration of one day. So it's kind of like, when if you're driving at 60 miles an hour, that does not necessarily mean over the course of an hour you will travel 60 miles. That means at the moment, this speedometer reads 60 miles an hour. So if you were to maintain that same speed always, then over an hour you would travel 60 miles. But it's an instantaneous piece of information. Just the fact that the units say per hour doesn't mean, it's going to stay the same. The rate's going to stay the same. So you can sort of think of 3 as the number of people that one person infects per day, but not really. It becomes more and more accurate to say that 3 is the number of people that someone infects, that one infected person infects each day. That becomes more and more accurate the smaller the time scale is. So if I changed the units, and rather than days, we made it milliseconds or nanoseconds or something, then, well, if I change the units, this number would actually change, because this number does have units. But whatever it changes to would be much more accurately representing the number of people that an infected person would infect in that time period. Okay, let me convince you that the 3 has units, and let's look at the units of it actually. So let's just make a new board here. Let's look at the differential equation. So this is the differential equation after rearrangement. If x has units of people and t has units of days, then x prime is another way of writing dx dt that has units of people per day. So the 3 here has units of people per day per person. Let me just write people. Which means the 3 here has units, let's say i.e. the units are 1 over days. So back here in this differential equation, just because of the units that x must have and the units that t has, and therefore the units that x prime must have, it must be that the 3 showing up here has units, and the units are inverse days. So if you were to change units from days to some other units for measuring time, then you would have to change that 3 accordingly.